Okay, so here are a few of my thoughts on this task and how you might want to use it in the classroom. So to begin with, when you first offer out this task to a class, chances are the pupils might start at the left-hand side and just go 1 plus 2 plus 3 all the way up to the 10 in the middle, and then back down the other side of the staircase, plus 9 plus 8 plus 7 and so on. And depending on how good their maths are, they might end up at the correct answer, which is 100, or they might be a few out either way. But if you do it with the whole class, the chances are enough of them get the answer of 100 that we can agree that that is the correct answer, and people might go back and check their original working and hopefully arrive at 100, which is great. But then we can ask the question, why? So why is it that the answer is 100, and can we have here an opportunity to specialise a little bit? So what if the staircase wasn't so big? What if we started with the very smallest staircase we could make, which would just involve one step, like so. So go up one step and that bit down, and that has a value of just 1, obviously. What about the next staircase then? So if we go 1 plus 2, and then back down again, 1. Well, this is slightly more interesting, so that has a value of 4. And then by the time you get to the third one, so 1 plus 2 plus 3, and then back down the other side, we get an answer of 9, and we can start maybe looking for patterns here. So it appears that these 3 numbers here are all square numbers. So they might notice that, or you might want to point that out to them. So does that mean we can make squares out of all these patterns? Well, the first one is a square. For this 4 here, we can just take this 1 here and pop it there to make our 2 by 2 square. And for this 9 here, well, we can take the down part of the staircase and turn it round and place it there to make a 3 by 3 square. So it appears to be the case that the answer to this problem, no matter how big the staircase is, always gives us a square number, which starts to explain this, why we got an answer of 100, 10 squared. We've made a conjecture here, so let's test it with the next staircase. So 1 plus 2 plus 3 plus 4, that takes us to the top of the staircase. And then we go back down the other side, 3, 2 and 1. And then it appears to be the case that the down part of the staircase we can always remove, and with a little bit of rearrangement we can make a square. So it appears to hold. We've got this answer of 16 here. Now what we're actually talking about here are triangle numbers, and we're saying that 2 consecutive triangle numbers make a square number. Now I did this with my 4-year-old actually just at the breakfast table the other day, and we were talking about step squads that they use as a sort of placeholder for triangle numbers. And my 4-year-old said, "Daddy, an up and down step squad always makes a square," which is a nice little conjecture that he made at 4-year-old. Later on down your mathematical sort of journey, you might start using the correct terminology of triangle numbers. 2 consecutive triangle numbers always make a square number, and depending on your algebraic skills, you might want to prove it formally by using the formula for triangle numbers. So the first triangle number would be n times n plus 1, and then that would be the up part of the staircase, and then the down staircase will be the triangle number before that, which will be n times n minus 1, obviously all over 2. And then when you do the algebra with that, it all simplifies nicely to just n squared. So you can see this task can span a huge sort of mathematical range and age, depending where they're at, but it's a lovely chance to behave mathematically a little bit. So as always, thoughts and comments in the thread below.